All right, welcome to video 3 on pointers. All right, in this video we're going to talk about pointers and passing arguments to functions. So the first thing we're going to do is we're going to talk about this little program here where we have variables and we make a swapping function. So I think the first thing we need to do is I need to go ahead and explain how you swap things. So let's go to the next video right here and talk about swapping. So if you want to swap things, for example, if you have int x and int y, okay, this is swapping, and you want, so x equals 10 and y equals 20, but say you want to swap their values. So let's draw a little memory map over here. This is not about pointers, this is just going over what swapping does. All right, so here I have my memory map. So when I declare x, I get a little piece of memory for x. And because we are in the pointer video, I get an address of x. And x gets assigned a value 10. And then I have y, and I get an address of y. You automatically get an address every time that you declare a variable, and all you have to do is put an ampersand in front of it to get the address. And y has a 20. Now say I wanted to swap these two. I wanted x to equal 20 and y to equal 10. Well, let's get a different pen color here. If I can get that to come up. All right, not sure why it's not coming up, but all right, anyway, so I'm not going to use a different pen color. So we're just going to say, what if I said x equals y and y equals x? All right, well, if I said x equals y and y equals x, then after this executes, x is 10, then x is going to be 20. And then if I say y equals x, then y is going to be 20. Now, clearly, I have not swapped the values. All right, so let's say, how do you swap then? All right, well, let's start with a new x and a new y. So I have x is 10 and y is 20. And I want them to swap. So in order to swap, what I need to do is I can't just swap them like this. I need to declare an additional variable. We can call that variable temp. So I have temp. So all I have to do is assign one of the two to temp and then make the copy. So what I would do is I could say temp equals x. So when I say temp equals x, then temp is temporarily holding what the value of x was. So now if I replace x, I have a memory of what x was. So then I could say x equals y. That would change this to a 20. And then I could say y equals temp. And then that would change y to a 10. And now I have successfully swapped their values. And it's important to understand how that works because moving forward we're going to be doing some examples on how it would make sense to use pointers in a swap function. It would not make sense to pass by copy in a swap function. So let's go back here and take a look at this code. All right, in this code we have a function where we have two variables, int a, and I think I'll just draw the picture right here so you can see it. I will use blue. All right, so I have int a and b. So I can make a little memory map right here. If my pen decides to write. There we go. And we have our memory map. And let's just draw little lines here. Okay. So in my main function, as you know, all execution starts at the first instruction in main. So I have a, and a is 3, and I have b, and b is 7. And now I'm going to make a function call to this function called swapping. Now swapping takes two arguments, two integers, and since it does not it just is a regular kind of function, it's called pass by copy. So this is a pass by copy. So what happens is when this function swapping gets called, which here's the function call right here, C is going to get declared and assign the value that comes in. So if A is being passed to swapping, what's actually getting passed is a 3. So this is just like saying int c equals 3, and what's getting passed here is a 7, so this is just like saying int d equals 7. So we would have, now these are local variables to the swapping function, and the a and b are local variables to the main function. So we can like make a little thicker line here to indicate that c and d are part of the swapping function, and the main function doesn't know anything about c and d. That was the big topic on functions when we learned about functions. So int c is going to get declared and initialized to the value of 3, and int d is going to get declared and initialized to the value of 7. And then we're going to declare a temporary, and we will then follow here, temp equals c. I'm just on this instruction right here. C equals d. D equals temp. So now we have successfully swapped C and D, but what happened to A and B? Nothing. Now why hasn't anything happened to A and B? Because we passed copies of our variables to the function, to the swapping function. We did not pass the address, we passed copies. So now in the next video, in the next slide, I'm going to show you what it means to pass by reference. This is called pass by copy. This is when you pass just the value that is held there. So A was a 3 and B is a 7, and you're passing the values of the variables, and these variables are getting declared and initialized. That's called pass by copy. All right, let's go to the next slide and talk about pass by reference. So just to review, before we get started on the pass by reference, let's review once again that we have integers, doubles, characters, and we have integer pointers, double pointers, and character pointers. And you can take any integer, say int num equals 6, and you can take any integer pointer like int pointer that points to the address of num. All right, so you can take any integer like num and turn it into an address by putting the ampersand in front of it, and you can take any pointer and turn it to value at by putting the asterisk in front of it. So that's just a little review from the previous video. Go back and look at that again, and let's take a look at this other code. All right, so this is passing by reference. So if you take a look, there's a little difference here in our function prototype and the data type that's getting passed to our function. If we go back to the other swap, you can see that there are no asterisks here. There are just regular pass by copy. This is pass by copy right here. Now, there's no pointers getting passed here. It's just like I showed you before. It's just going to make a copy of it. It is not accessing the data directly in memory. Now the way you do it by pass by reference is like this. So if you take a look at this, let's get a red pen color here. Here we have, this is going to be pass by reference. And what does that mean? That means that we are not passing, when we call this function, we are not passing the 3 and the 7. We are passing the location in memory where A is located and the location in memory where B is located. Hence, we're putting the ampersand in front. So let's draw a little memory map over here, and we can follow along what is happening. And we can still separate it by locality here. So this is our main function. So we just start right here at the beginning. We have A, and A has the value 3, and A also has an address. So this is the address of A. That happens at this declaration and initialization. We have B, and B has the value of 7, and B has a location. So this is the address of B. and then we call the swapping function. So the swapping function does not take, these are not integers, these are integer pointers. So what's happening here, C is not getting declared, we're not passing a 3 in here, we're passing the location where this is located. Say this could be location 500 or location 5000. So we're passing in a location. We're passing in the location, and what's happening right here at this thing, it's going int C pointer equals the address of A. That's what's happening with this argument right here. And with this argument right here, it's going int D pointer equals the address of B. If you see, we're passing in here the address of B and the address of A. So what is actually happening there? C pointer is getting declared, and it's going to point to the same location here that we're telling it to point to. This could be location, whatever location A has been given in memory. And here, D pointer is getting declared, and it's going to point to the same location in memory where B is located. So how do we access that information? Well, if we have a pointer that's pointing to this location, we can dereference that pointer. That means we can go to where C pointer points and put an asterisk in front of it and get to that value. That's called going to the value at. This is called pass by reference. So let's see what happens here. Inside of the swap function, this TMP is going to get declared. TMP is going to get declared, and that is the local variable at this for this function. But then what's going to happen, because we're using pointers and pass by reference, we're going to go where C pointer points, which is all the way up here, dereference it by going to the value at C, by putting an asterisk in front of it and going to the value at C pointer, and the value at C pointer is a 3. So this would be a 3, and then that 3 is going to get assigned to TMP. Then we're going to go to the value at CPTR, which is right here, and the value at DPTR and assign that to this. And then we're going to go to the value at DPTR and assign what temp is. So now we have successfully swapped A and B from inside of a function by passing by reference. And you probably have to watch this video a couple times to follow what's happening, and also the code examples are on Canvas, so you can take the code examples and put them in the compiler and add printfs all over the place to follow what's going on. Let's do the next example. All right, the next example is going to take, we have this function called calculate2 that is going to take 4 arguments. It's going to take 2 pass by copy arguments. Maybe if I got my pen here. All right, it's going to take 4 arguments. This is a pass by copy argument, and these 2 are pass by reference. Now, yes, I could leave the, sorry about that. Yes, I could leave the names here, but the name, I just wanted to reiterate that the function prototype, all the function prototype says is the name of the function and what type of data you need to pass to it. Now, Better Code would also have a comment here describing what the function does, but I didn't have enough space, and so I wanted to make sure that you guys could follow what's going on. So we have a function, it's called calculate2, and it takes 4 arguments. 2 integers in which it's going to make a copy of the value of those integers as it's passed, and 2 integer pointers which are passed by reference. 2 passed by copy, 2 passed by reference. And what this function does is it calculates the sum of the first 2 arguments and stores it at the value at sum pointer, and it calculates the product of the first 2 arguments and stores it at the value at product pointer. This is a very simple function, but this is just to illustrate what you can do with pointers. So let's pick another color and draw our memory map over here. All right, so it might get a little messy. I'm just going to go right up here and draw my memory map. The best way to follow what's going on with pointers is to make a memory map and to, practice and go over it again and again and start at the beginning. So we start right here at the first instruction in main and follow what happens. So the first thing that happens is num1 gets declared and assigned a value of 5, and it gets an address. This is the address of num1. Then num2 gets declared and gets assigned a value of 4, and this is the address of num2. Then sum gets declared. We don't know what that value is, but we know that sum has an address. And prod gets declared, and we know that prod has an address. So that all just happened in this first statement right here. Now we're going to make our function call to calculate 2. Calculate 2 is going to take 4 arguments. The first 2 arguments are passed by copy. So if num1 is a 5, so a 5 is going to come in here. A 4 is going to come in here. So arg1 is going to get declared and make a copy of what num1 was, which was a 5. So we're going to have another copy of that. arg2 is going to get declared and make a copy of what num2 was, which is a 4. These are passed by reference. So what's going to happen here is, I don't know why I can't get another pen color. Okay, anyway, so this is a little bit of technical difficulty here on the pen color, but we'll continue. All right, so what's going to happen here is the address of sum is going to come in here, and the address of prod is going to come in here. So what does that mean? That means that sum PTR is going to get declared and is going to point to the same location in memory where sum points. And prod PTR is going to get declared and point to the same location in memory as prod. So right here. So what we care about is the value that's going to go right here, which this value that's going to go right here would then be the value at sum PTR. That's this value right here. And this value that goes right here would then be the value at prod PTR. And how do we do that? We go to where prod PTR points and we get to the value at that. So this is prod PTR is pointing right here, and that's the value at prod PTR. Sum PTR is pointing right here, so that's the value at sum PTR. So if you read this instruction right here, we're going to take arg1 and arg2, add them together, which is going to be a 9, take that 9 and assign it to the value at sum PTR. We go where sum PTR points and we put a 9 there. And look what's also happening. Now sum is getting the value of 9. That's why it's passing by reference. It's happening through memory, right straight into the location. Now this seems very silly, but when you get into more complicating programs that you're passing more data to your functions, you don't want to make a bunch of copies of data in your program. You want to be able to just access memory directly and manipulate it. So we use very simple examples, but the truth is this is used more often with more larger amounts of data. So over here we're going to take arg1 and arg2. If you multiply 5 times 4, that result is going to be 20. We're going to take that 20, find where prod pointer is pointing, which is right here, and that's going to be assigned to the value at, see the value at prod pointer, and it will also then affect sum and prod, which are in the main function. So when I print back sum and prod, oops, I have to fix that. So if I were to print back here sum and prod, then it's going to print the sum, which is a 9, and it's going to print the 20, which is the product, and those are the result that were done in the function. And really what I'm illustrating here is a function that's actually has output parameters. So essentially this function, as we've learned earlier, if you have one return type, a function can only return one thing. But in this example, because we used pass by reference, our function is essentially returning two things. Through its output parameters, it is returning the result of two calculations by reference.